In this presentation, we'll describe the main differences between two versions of the Pan-European Climate Database, specifically the recent PECD version 4.2 compared to the previous PECD 4.1. We start by looking at some of the recent development in the PECD. So in January 2021, the PECD 3.1 was released, which had historical data only, and these were taken from the climate reanalysis called ERA 5, covering the period 1980 to 2019. Specifically, no projection data were available for this version, and the data were available through ENTSO-E. Then, after the Copernicus Climate Change Service contract started in September 2022, we worked towards the PECDv4.2, which included an extended ERA 5 dataset from 1980 to 2021, but especially we included projection data from the regional climate models called Eurocordex and two scenarios, emission scenarios, so RCP 4.5, which is a mid-range, and the high-range 8.5. And the three climate models were selected. Data were available still through the ENTSO-E. In September 2024, we published the new 4.1 version, which now moved to climate data from the global models, CMIP6, still covering the European domain, but the models are global, and new scenarios, also called SSP. In this case, we use 245, which is the mid-range, and three climate models covering the period 2015 to 2100. Availability now started to be through the public climate data store of C3S. And currently, we are working towards the publication of the version 4.2, which has some improvements to the modeling and especially expansion of the number of climate models and number of scenarios for the projections. And the data will also be available through the climate data store in Q2 2025. There are also ideas for future developments, but these are not confirmed yet, and they are listed here in the last box. This is just a reference slide. I won't go through all of it, just to highlight what the main differences are. So there is improvements in onshore wind, offshore wind, and PV modeling, which we'll cover more in detail in the next slides. So just summarizing the main differences again in terms of projection data. 4.1 has had three projection models, only one scenario, and limited cover period. With 4.2, we extended to 6 projection models, 4 scenarios, and extension of the period, both for the historical and the projection data sets. The specifics of the models are given in these slides. Again, I won't go through the details, but you can have the names here of the models as well, the specific SSPs. You can see that the scenarios are 1.126, which is the lowest emission scenario, so high mitigation, up to 585, which is pretty high emission scenarios. And the historical period covers the period 1950 to 2024 and will be updated regularly. And the projections cover the period 2015 to 2100. Now we cover some specifics in the differences, particularly here in the way we have handled the wind speed. There's some processing that required to improve the way the wind speeds are produced, starting from the ERA 5 reanalysis. So this is for the historical period. And in the 4.1 at the top, we see the method that was used is the cumulative distribution function for the bias adjustment, and the reference data set was a regional reanalysis called Cosmo RIA 6. And we were using daily averages, and then we were computing the wind at 100 meter through power law and alpha coefficient computed from the original wind data. However, we found that there were some issues with the diurnal cycle and also some of the wind speed data. So the wind speed was underestimated. So we moved to a different approach with 4.2 at the bottom here, and we used a simpler method called the delta method. The reference data set now is the Global Wind Atlas version 2, and then the wind speed at 100 meter was bias adjusted using the ERA 5 wind speed at 100, so there's no power law applied in this case. And the adjustment of the ERA 5 wind speed at 100 meter was done in the same way as the wind speed at 10 meter using the Global Wind Atlas, which provides the two levels, the 10 meter and 100 meter. Following the changes in the historical data set, we also had to update the projection data set. Specifically, we had to rerun the cumulative distribution function transform method for bias adjustment using now the new reference data set, adjusted, as we said, using the Global Wind Atlas. And also we changed the way we calculate the wind speed at 100 meters. So in 4.1, we used alpha coefficient computed from the original wind data, whereas with 4.2, we use alpha coefficient computed from the bias adjusted wind data set. Now we look at some of the key differences in the wind power modeling between, again, version 4.1 and version 4.2. So there are some improved validation metrics in 4.2, which demonstrate improved capacity factor through these metrics like the Earth mover distance and correlation. There is enhanced accuracy, which results in a better alignment of simulated generation distributions with measured data for most countries, especially in onshore wind regions. And the data handling was refined, and we included also curtailment effects in measured data for several regions, like in France, Hungary, Spain, and Italy, especially because for this region we had access to additional data sets other than the transparency portal. And also we used the standardized methods for raw and corrected generation data comparison. There were some region-specific improvements, again, based on the data set that we were able to receive from individual countries. In onshore wind, for example, we had announcements in validation from Austria, Spain, Hungary, and also slight correlation improvements in Denmark, Finland, and Norway, despite the measured data uncertainties. Also, offshore wind was marginally improved for Germany and Belgium, with, however, mixed results for Denmark due to data inconsistencies. And then finally, we show some of the updates to the solar PV modeling. One major update was that we started to model different types of PV. So from a generic PV in version 4.1, there was just one typology. Now we have four. The four typologies are rooftop residential, rooftop industrial, utility scale fixed axis, and utility scale with one axis tracking. Each typology is characterized by a particular daily and annual seasonality and overplanting factor, which can be user-defined. These updates have led to overall more accurate results as tested over the historical period. These are based on averages over countries or PECD zones, not at the individual PV farm or system. And there are also, with this approach, more flexible options to test different PV scenarios, because we can combine the typologies in a very flexible way. So this concludes the short description of the differences between 4.1 and 4.2 of the PECD. Thank you for your attention.